Alright, this is Math 2, Unit 12B. This is the review. So here we go. As you can see, we have a show coming up pretty soon. So if you're not planning on going, make plans to go. May 11th through 20th. Come on and watch the show. Here we go here, Math 2, Unit 12. First one says 3 equivalent expressions are shown below. Select the form that reveals the maximum value of f of x without changing the form of the equation. The one that helps us out the easiest to find that maximum value or minimum value is vertex form. And the one that happens to be in vertex form is this one right here, choice C. That's our vertex form. Remember what happens there is we take the opposite value, 2, and we take the last part here to make our y, and so our vertex would be at 2, 12 if they were asked you to solve that part there. Number 2, says 3 equivalents are here. What shows their zeros without changing the form? The easiest one for showing the zeros is right here, choice C. Our zeros would be set up like this, essentially the opposite. So you have -3 and +7. Of course, you would solve that by saying x plus 3 equals 0, setting equal to 0. You subtract 3 from both sides, so x equals -3, and that's how you arrive at that conclusion there. So that one shows you your zeros right away. Again, this is vertex form, and this is kind of the factored out form, and this is the standard form here, where you have your A, your B, and your C. Alright, so we have a C so far. Number 3, what is the value of C such that that is a perfect square trinomial? So to solve this one here, we take our B value. The formula here is B over 2 because we're squared, and we square that. So this is our B, which is 20. So we have 20 over 2 squared. 20 divided by 2 is 10, and 10 squared is 100. Number 4, the same idea. We take our B value, -8 over 2, and then we're going to square that. -8 divided by 2 is a -4 squared, and -4 squared is still 16. Number 5, we want to find the vertex of the parabola here. Okay, so to find the vertex here, what I would recommend that we do is we move some things around and try to get it into vertex form. So what I did is this. I went ahead and went x squared plus 4x equals 16. I moved the 16 to the other side. Okay, so I'm setting this equal to 0 to start with. I'm going to move the 16 over to there. Now I find the 4 over 2 squared. 4 over 2 squared. 4 divided by 2 is 2. 2 squared is 4. That is my perfect square I'm looking for. So I rewrite this as x squared plus 4x plus 4 equals 16 plus 4. Okay, so now that's my perfect square number. This becomes x plus 2 squared equals 20. And to put it in finally in vertex form, I move the 20 over to here. I end up with x plus 2 squared minus 20. So my vertex would be the opposite of this, which is -2, -20. So I basically found the perfect square trinomial. I turned this into a perfect square trinomial here in order to then put it back into vertex form to solve for that, -2, -20. I'll do the same thing here. Okay, so let's work on the 12. Okay, so we have 12 over 2 squared. 12 divided by 2 is 6. 6 squared is 36. So if I rewrite this equation, I rewrite it as x squared plus 12x plus 36 equals, moving the 9 to the other side, -19 plus 36. Alright, so that's just moving things around there. Now this becomes x plus 6, because there's a plus there, x plus 6 squared equals 36 minus 19 is going to be 17. So to put it in vertex form, I would say, technically I would say f of x equals x plus 6 squared, and I move the 17 back to the side, minus 17. So my vertex would be the opposite of this, -6, and that number there, which is -17. That becomes my vertex for number 6. For numbers 7 through 8, we're going to use this equation right here. I'm not actually sure what this equation is about. This is something totally different over here. And when I looked at Mr. Lee's notes, I noticed he had crossed this out, so I'm going to go ahead and cross that out as well. That's a whole separate problem from that one, so I'm not sure if it just got copied over wrong. Not positive. But what they're wanting you to do is complete the square and then put it, if you notice, into basically partially, well, not partially. We're going to complete the square and not put it back in vertex form. So what we'll do is we will do x squared minus 12x equals negative 40. Okay, moving that over to there. And then we find the perfect square by doing 12, and actually, sorry, it's a negative 12 over 2 squared. Negative 12 divided by 2 is negative 6. Negative 6 squared equals 36. So this whole formula then becomes x squared minus 12x plus 36 equals negative 40 plus 36. So we then have x, we have a minus here, minus, what number can you square to get 36? 6, right? And then we have it squared, equals negative 40 plus 36 is negative 4. So we take a look at what should be in here. What are the things that should be in these equations here? It says fill in the number for the square. Now notice the square is just right here. Okay, so be careful on this part here. They already put the minus sign there, so what number goes in the square is simply 6. That's what's in the box there. So we would say B. And for number 8, they want to know what goes inside the circle here. Well, the circle is going to be this part right there. So number 8, we would say, is negative 4. I'm going to flip it over. Take a look there. So the number that goes inside of there should be negative 4, and that comes from the front page. Okay, moving on, number 9. Solve for x. Alright, same idea. Now we're going to solve this out. So the first thing I would do is subtract 18 from both sides. So I have x squared plus 6x equals negative 18. Now I make a perfect square trinomial. I'm going to do 6 divided by 2 squared. 6 divided by 2 is 3. 3 squared is 9. I'm going to add 9 to both sides of the equation. Plus 9 here, and negative 18 plus 9 there. Perfect square. So we have x plus, because the plus is there. What number gives you 9 when you square it? 3. So we have squared there. Equals a negative 9 over here. Now because I want to solve it, I'm going to keep going. I got to get rid of the squared, so I take the square root of both sides. This becomes x plus 3, and this becomes, well, I can't really do the square root of a negative number except when I use an imaginary number. So square root of negative 9 is 3i. Okay? Now I'll subtract 3 from both sides, and I end up with x equals negative 3 plus 3i. Oh, sorry, plus or minus. Don't forget my plus or minus there. Plus or minus 3i for my answer to that one. Okay. For the next part, I want to know, does it have a real solution? Remember, the way you find out if it has a real solution is you use the part of the quadratic equation, just the b squared minus 4 times a times c. If you end up with a negative answer, then the answer is going to be that it has no solutions. So n, negative, no. If your answer happens to be 0, it will have one solution. And if your answer happens to be positive, you're going to have 2 solutions. Alright, so what we're looking at here is our a, our b, and our c value. And again, we use b squared minus 4ac. So in this one, we would say 6 squared minus 4 times 3 times 3. That's my b, a, c. So I have 36 minus 4 times 3 is 12. 12 times 3 is 36. So 36 minus 36 equals 0. And when it's 0, we have one solution. One solution. And one solution means it has one real solution. I should say real here. For the next one, we have x squared minus 81. I don't actually have a b value, so my b value is 0 squared minus 4 times my a value is 1 times my c value, negative 81. So I have an 81 and a 41, and 81, negative 81 times a negative 4 equals a positive 324. Now again, it is positive, which means it's going to have two real solutions because it's positive. The next one, I will do b squared, and I have a negative 4, so negative 4 squared minus 4 times 1 times a 10. So negative 4 squared is going to give me 16, and this becomes minus 40. 16 minus 40 is negative 24. That's a negative answer, so there are going to be no real solutions. And our last one here, again, there's my b. So b squared is 10 squared minus 4 times a times c. So we have 100 minus 16 times 8, right? 16 times 8, which is 128. So 100 minus 128 is negative 28. Again, that is negative, so we would say no real solutions there. Okay, moving down to the next part. I have to simplify here. To simplify this, sometimes we're going to distribute, sometimes we'll just find common terms or similar terms, or like terms, sorry. So here we're going to distribute. We do 6 times 2 is 12. 6 times a negative 3i is a negative 18i. 2i times 2 is plus 4i. And 2 times 3 is a negative 6i squared. Remember that the value of I squared is always equal to negative 1. Okay? So now I'm going to group up my like terms here. And I have 12, and I have negative 18 plus 4 becomes a negative 14i. And this becomes a negative 6 times a negative 1, which becomes a positive 6, right? So 12 minus 14i plus 6, and I group my like terms. 12 plus 6 is 18, so I have 18 minus 14i as my solution. Last one on this page here, same idea, except I have to distribute one side. This stays 2 minus 4i, and here I do negative 3 times 4 to get a negative 12, and negative 3 times a negative I gives me a positive 3i. Like terms, 2 minus 12, so I have a minus 10, and here I have a minus 4i and a plus 3i, which leaves me with a negative I. So my answer is simply negative 10 minus I. Number 14, what we're going to do is we're going to simplify this one by beginning by multiplying the top and the bottom by 3i. For this part here, I'll distribute it over the top, so I end up with 3i times 2 is 6i, and 3i times 5i is going to be 15i squared. And on the denominator, I end up with 3i times 3i, or 9i squared. Okay, now remember, we said that I squared is equal to a negative 1, right? So we have 6i plus 15 times negative 1 over 9 times negative 1. Again, keep rewriting this here. This ends up as 6i minus 15 over minus 9. This is where I'm at so far. One more step I can do here. I want to change, or two more steps, change the order around to write it as negative 15 plus 6i over minus 9. And I'm going to notice here that they each have a 3 in common. I can factor 3 or reduce everything by 3. 3 goes into negative 15 5 times, so I have negative 5 there. 3 goes into 6 2 times, so plus 2i. and 3 goes into here 3 times for a negative 3. So if I rewrite that cleanly, I would have negative 5 plus 2I over negative 3 for my answer for number 14. Number 15, same idea, except what I want to do here is I'm going to then multiply by this. Instead of 2 plus 3I, I multiply by 2 minus 3I. And I do that for the top and the bottom. Alright, so I'm going to distribute. 3 times 2 is 6. 3 times a negative 3I is going to be negative 9I. Negative I times 2 is a negative 2I. And negative I times a negative 3I is a positive 3I squared. And that's all over. Distributed on this guy now. 2 times 2 is 4. 2 times a negative 3I is negative 12I. 3I times 2 is plus 6I. And 3 times 3I is negative 9I squared. Alright, it's a little messy here. Right, just a little bit. Just a little bit. I get 12 there. That's not right. I shouldn't have 12. That should be 2 times 3. It should be 6I. Sorry about that one there. Should be a negative 6I. Not sure I got a 12. Anyways, now we combine our like terms. Alright, so I have up on the top, I have 6. I group those together, minus 11I, and 3 times a negative 1 is a negative 3, all over. 4, and those cancel out, and I'm going to do minus, and I have 9 times a negative 1. Okay, so when I rewrite this one, 6 minus 3 is 3, minus 11I, and on the bottom I have a negative 9 times a negative 1, which is 9, so basically positive 9 plus 4 is 13. So that's my solution for number 15. Number 16 is a little simpler. We do 4I times 6I to get 24I squared, and 4I times a 4 is a plus 16I. This becomes a negative 1, so basically we'll end up with negative 24 plus 16I. And that's my solution for number 16. Okay. So this next one, I'm going to show you a couple of them here. I look to see, I want to find out if it's linear, quadratic, or exponential, okay, based upon the change in the y value. When I look at this one, I'm going from negative 2 to 0. I'm adding 2, adding 2, adding 2, adding 2. Because that's a constant change there, nothing's happening, we would call this a linear equation most likely. Okay. On the next one, I can go here from 6 to 3, I'm going up, or I'm doing a minus 3. From 3 to 2, I'm subtracting 1. But from 2 to 3, I'm adding 1, and here I'm going to be adding 3. Okay? So to me, what that tells me is I'm changing from one to the other, and I'm changing my direction at this point here, aren't I? I'm going down, and then I start to go back up. It tells me I'm going to be doing one of these kind of things, right? Some kind of loop-de-loop of some sort. And I probably have a vertex somewhere around that area. So that tells me that this is going to be a quadratic equation. On number 19, when you look at what's happening on number 19, these are the numbers that were written on my form here. To go from 0.25 to 0.5, we are adding 0.25. From here to here, we're adding 0.50. From here to here, we're adding 1. And from here to here, we're adding 2. So we are increasing, but we're increasing by like a little bit more each time, which means this would be exponential at this point. Mr. Lee, I think, was using some different numbers in his. I believe on his sheet, and one of the things I saw was 1, 3, 9, and 27, and 81. Again, same kind of thing. We're multiplying by 3, multiplying by 3, multiplying by 3, multiplying by 3. So that's going to be an exponential in that type of action too. Okay, number 20. match the function with what kind it is. This is a typical y equals mx plus b. This is a basic linear equation, something that you had back in 8th grade, most likely, first time you saw that, or maybe 7th. This one here we have our a squared plus bx plus c. This is a basic quadratic function here. And number c, because we have the exponent there, we would call this one exponential. ABC. Alright, number 21 says determine the equivalent function to this in the form of that. So this is vertex form, and so basically they're saying rewrite this in vertex form, which we did on a couple other ones. So to do that, we do x squared minus 10x minus 11 equals 0. I'm going to add 11 to both sides, so x squared minus 10x equals 11. I'm going to find my perfect square, so I do negative 10 over 2 squared. Negative 10 over 2 is negative 5, squared is 25, so I have x squared minus 10x plus 25 equals 11 plus 25. This becomes, I have an x, what number gives me 25 squared? I'm squared, 5. I have a minus there, so put a minus there, squared. And we're going to say that's equal to 11 plus 25 is 36. Now I want to get it back into vertex form, so I'm going to move that back over. And we will now say that f of x, oops, set up a little bit for you, that f of x is equal to x minus 5 squared minus 36. And that becomes my vertex form for that equation by first creating a perfect square. Alright, moving on to the back side of that, number 22. Alright, so we have our equation right here. This is going to be some sort of thing where you take a ball, we throw it up, and it comes back down. So it starts at 0, and it comes down over here at 0 at some point, and it has a high point at our vertex. So how long does it take to reach its height? What is our vertex going to be? When we had one of these things, the way we found our vertex is we took this one, we did negative b over 2a. Remember this one from last unit? And we said our b was 64, so negative 64 over 2 times a, which is negative 16. Okay, negative 64 over a negative 32 is going to equal a positive 2. That's my x value of the vertex. Now because it didn't ask what the height was yet, it just wants to know how long does it take to get from 0 to here. It tells me that that is at 2 seconds. Okay, that's my x value. The height will be the y value. To find the y value, we plug the 2 back in the original equation. So we do negative 16 times 2 squared plus 64 times 2. And that's how we'll find the y value. We're plugging in the x value here into the equation up there. So 2 squared is 4. Negative 16 times 4 is going to be a negative 64. Plus 64 times 2 is 128. And 128 minus 64 is 64. So my height is going to be 64. In this case here, looks like, well, I don't know if it's 64 feet, but it's 64. 64 something, probably feet. Doesn't tell if it's feet or not. Okay? So the height that's going to be at 2, 64 is where that's going to be. So if I was to mark this here, this would be 64 on the axis, this would be 2. Now when does it hit the ground? I could do it a couple ways. I'm trying to find out basically the ground is when it equals 0. That's what I'm trying to find out. The ground is 0. Now if you notice, because we're doing a nice little curve there, probably going up and down, because the halfway point is at 2, it took from 0 to 2 to get the height. It's going to go from 2 plus another 2 to get to the next point down. So I could look and estimate that it should be 4. 0 to 2, 2 to 4, should be 4. But the way we would solve that is we would actually solve it by setting it equal to 0. So we would say, for our equation, negative 16t squared plus 64t, and we set it equal to 0. I can factor a 16 out of both of these, and I can also factor a t out of both of them. So on this side, I'm left with simply a negative, I'm left with a, sorry, what am I left with here? I'm left with a negative t, and over here I'm left with a minus 4. Is that right? Seems a little funny for me right now. Okay. Oh, t squared. Yep, we're okay. So, pull that out of there. Actually, I'm going to pull this out here. I'll pull a negative out, make that a positive, and that a positive. So, we end up with, so this becomes 0. And here we do t plus 4 equals 0. So t is going to equal, I wrote negative 4. That should be wrong. Should be somehow t minus 4 actually, is what it should be. I should end up with 16t times t minus 4. So we're going to say it's at 4 is where it should be. Somehow I messed up something there. Anyways, you should get 4. That's the idea. Number 23a. Alright, here's our A, here's our B, and here's our C. So we're going to start by plugging things in. So we're going to do negative B. B is already a negative 6 times a negative 6 squared times 4 times A, which is 4, times C, which is negative 8. On the bottom we have 2 times A, which is 4. We have to solve this for A. Solve this for X. So it looks like this when you rewrite this out. We end up with a negative. Negative is 6 plus or minus the square root of 6. Negative 6 squared is 36 plus negative 4 times negative 8 is going to be a positive 128 all over 2 times 4 is 8. 128 plus 36 is 164 over 8. There really isn't a nice simple square root of 164, so that actually becomes 6 plus or minus about, and I estimated mine about 12.8 over 8, and then we're going to solve it both ways. We're going to say 6 plus 12.8 divided by 8 equals 2.35. And then 6 minus 12.8 divided by 8 equals negative 0.85. So those become the two solutions when I solve for x. Number 24. We have to solve for x in 2x plus 1 equals x squared plus 4 algebraically and graphically. Algebraically, what they want us to do is say, let's do 2x plus 1 equals negative x squared plus 4. Let's move some things around. Let's add x squared to both sides. So I have x squared plus 2x, and I'm going to subtract the 4 from both sides, minus 3 equals 0. Now from here, I have a couple options. Because I'm trying to solve it, I'm looking for where things equal 0 at. I'm going to go ahead and factor this one out because I like factoring. And they're small numbers, and I have just an x squared in the front, so I know that's x and that's x. I have a 3 here. What can I multiply together to get 3? How about 1 times 3? So if I put a 1 and a 3, I'm in good shape so far. I know I want to end up with a positive 2x. So I need the 3 to be large and the 1 to be negative, so that when I multiply this part, I end up with a negative 3 right there. Right? But if I do my outsides and insides, I have a 3x and a negative x for a positive 2x. Okay, so I know I had the right information there. And that again is equal to 0, which means that if I do x minus 1 equals 0, x will equal 1. It's one solution. Now if I do x plus 3 equals 0, then x will equal negative 3 as another solution. Okay, so now I come over here, and if I go to x equals 1, okay, I should have some solution on this line here, somewhere around here. I should have a solution. That's not a solution. And I should have another one at 1, 2, 3 over there. Now I need to find out where those are going to happen at. That's just for now. Okay, to work on the graphing part, let's start with the 2x plus 1. 2x plus 1 is a linear equation, right? Because it's just a slope and a y-intercept. My y-intercept for this one is at 1. So here's my 1. And my slope for this one is simply 2 over 1. Right? That's my slope value, rise over run. So if I wanted to plot it, I would say 1, 2 over 1, 1, 2 over 1. And if I want to keep going on the other side, I go down 2 over 1, down 2 over 1. And I'm going to go one more because I know you should have the solution somewhere around 3. So I'm going to go 1, 2 over 1. Okay, so that's my first line that I create. Alright, now to look at the next one, I have negative x squared plus 4. Okay, it's a square, which means it's quadratic, which tells me it's negative. This should do some kind of curving down like so, because it's a squared and it's a negative there. And I should have a vertex of some sort as well. So if I want to find the vertex, this one's nice and easy. The vertex is going to be when if x is 0, y is going to be 4, if I plug that in there. So at 0, I go 1, 2, 3, 4. There's my vertex for this equation right there. So what I would suggest would be to pick a couple points, x and y, and again they're going to mirror each other. So if we have it 1, if x equals 1, then we do negative 1 squared plus 4. I'm plugging that back in the equation. So 1 squared is 1, negative 1 plus 4 is a negative 3. So at 1, no, sorry, not, I think positive 3, negative 1 plus, yeah. So 4 minus 1 is 3, sorry. So at 1, we're at 3. Okay, that's one of my solutions we've already talked about. And I'm going to do another one. I'm going to do 2. So at 2, we get minus 2 squared plus 4. So 2 squared is 4. So we have negative 4 plus 4, which is 0. So at 2, 1, 2, we're at 0. Good so far. And then we're aiming for a 3. So let's put a 3 in here. So at 3, we have minus 3 squared plus 4. 3 squared is 9, so negative 9 plus 4 is a negative 5. So at 3, we're at 1, 2, 3, 4, 5. Now I can mirror this 1, 2, 1, 1, 2 to this side here, and 3, we're at negative 5 here. And so this parabola would look like this. And so graphically, to prove it, what we're saying is, here's the solution right there, and here's the solution there. We're looking at where do the two graphs intersect. And they intersect right here at negative 3, 5, and they intersect also at 1, 3. That's where they intersect at. And those become my solutions algebraically and graphically for that equation. Alright, flipping it over. Number 25. It says find the solutions here for f of x equals g of x. Well, my solutions are going to be at this point and also at this point. This point here looks like it's somewhere at about negative 1. And this one looks like it's at about 3. So we would say C is where my solutions are going to be. Number 26, they do not intersect anywhere, so we would say there are no solutions. Okay, because they're not crossing at any point. Number 27 just reads funny. I'm not sure why, but it says here's this thing here, right? That quadratic function. The points m, 0 and n, 0 both on the graph, and m doesn't equal 0. Select the consecutive integer intervals that contain the value of m and n. We're basically saying, okay, this is where y is at 0, right? So y is at 0. So somewhere around here, y is at 0. Somewhere around here, y is at 0. So where is that? Well, it's somewhere between -3 and -2, right? -3 and -2. And it's also somewhere between +2 and +3. That's where it's happening. So when you read up here, where could that be? Here's between -3 and -2, matches that. And between 3 and 2, matches that. So we would say choice B. So it's a weird, strangely worded question, but you get the idea. It's kind of saying, where is that at? It's somewhere between those 2 points. All right. And that's it for the review for 12B. Hope that helps.